In this video, we will look at two different volumes of solids examples. So the first one, we're going to have our region that is bound by y equals 2x minus x squared, y equals 2x, and x equals 2, and we'll rotate it around y equals -1. So first we'll draw it. 2x minus x squared, if you pull an x out, that's really x times 2 minus x. The reason that's helpful is it means our roots are at 0, 0, and 2, 0. When you sub in 1, you'll get 2 minus 1, which is just 1. And then it's a parabola opening upside down. So that's our y equals 2x minus x squared. Y equals 2x has a y-intercept of 0. So then it's going up 2 over 1. So we'll have a graph that looks something like this. And then we're cut off at x equals 2. So this is the region that we are rotating, and it is going around y equals -1. So it's clearly not disks because it's not resting against the line that we are going over. So we have to decide shells or washers. Shells we would draw in our slices parallel to the line we're rotating around. Well, the problem would be where that upside down parabola is there. When you draw on those slices, they don't go all the way through, so therefore we can't do shells. Washers, you draw on your slices perpendicular to where it's rotating around. So a general slice that we would then rotate around would be something like this. Well, notice with those slices, the outer and the inner is always the same thing. So this plays nicely for washers. So we will do our integral. Our thickness is in the x direction, so it will end up being dx, meaning we need to know what's our starting x value of our region and our ending x value of the region, which should be 0 and 2. We're going to do pi times radius squared for the outer minus pi times radius squared for the inner. So we'll have pi this green length that I just drew in, because it's connected to the x-axis, would be y. But we still have to add one more onto that to get to our line that we are rotating around. So our outer radius will be y plus 1, but we can't put in y because it's dx. So our y for that outer radius would be our line, so therefore it would be 2x plus 1. And it's radius squared, so we have pi times 2x plus 1 squared. Minus pi, and then we'll have our inner radius squared. Well, again, it's going to be y plus 1, but it's just we have a different y this time. Our y now is the parabola, so we'll have 2x minus x squared plus 1 squared. And now we've just got to solve our integral that we have set up. So we'll pull the pi out front. We'll be from 0 to 2. If we FOIL out 2x plus 1, we'll get 4x squared plus 4x plus 1 minus, and then parentheses. Let's maybe take this cubic and we'll multiply it together off to the side, because that'll take a little bit of work. So we've got 2x minus x squared plus 1 times another 2x minus x squared plus 1. We'll distribute the 2x through to everything. and we'll get 4x squared minus 2x cubed plus 2x. We'll distribute the negative x squared through to everything, and we'll have negative 2x cubed plus x to the fourth minus x squared. And then we'll distribute the 1 through to everything, and I'm just going to write it underneath so it doesn't run into where we're going to do our integral. So when you distribute the 1 through, you'll get 2x minus x squared plus 1. And if you combine your like terms, we've got 1x to the fourth. We've got a minus 4x cubed, because you had minus 2 and minus 2. We've got plus 2x squared. And that's from the 4x squared minus x squared minus x squared. You have plus 4x, that's from your 2x and your 2x. And then we've got plus 1. So that will be in our second in our parenthesis here, which we will be negating. And we'll distribute our negative and combine like terms. So we'll have pi again. We're going from 0 to 2. We're going to end up with a negative x to the fourth. We'll end up with a positive 4x cubed. We're going to have 4x squared minus 2x squared, so that'll give us just plus 2x squared. We'll have 4x minus 4x, so that'll be gone. 1 minus 1, that'll be gone. And then our dx. We are now ready to take our antiderivative. So we'll have pi, we'll have negative 1/5, x to the fifth, plus x to the fourth, plus 2/3 x to the third, and that'll be evaluated from 0 to 2. So we'll have pi, when we sub in 2 to the fifth is 32, so we'll have negative 32 fifths. 2 to the fourth will give us 16. 2 cubed is 8, times 2 is 16, so we'll have 16 thirds. And then this will all be 0, so we'll get wiped out. If we add those together and multiply by pi, we'll end up getting 224 pi over 15. And that is the volume of our solid that is formed when rotating our region around y equals negative 1. And we'll look at one more example, but we're going to see how we can do it in both ways, with washers and shells. So we're going to find the volume obtained by rotating the region y equals x, x equals 1, and y equals 4 over x around the y-axis. So we'll start out by drawing our picture. Let's start with y equals 4 over x. At 1, get back 4. At 2, we get back 2 when we sub it in. And then at 4, we'll get back 1. So our graph is going to look something like that. Y equals x, you're just going up 1 over 1 each time. And then we have x equals 1. So we have that as well. So this is our region here. Our green curve, our blue y equals x, and then the red x equals 1. We want to rotate around the y-axis. So let's start off with washers. We would have to draw in our slices perpendicular to where we're rotating around. Well, when you draw in slices perpendicular to where we're rotating around the y-axis, notice the outer function changes from the green to the blue depending where you are. So when we do this with washers, we're going to have to split it up. We'll do the top half doing green minus red, and then we'll add on the bottom half, blue minus red. And again, the reason we're doing that is because the outer function is changing. So the first integral we will do is the blue one. When we do our slices, their thickness is in the y direction, so we'll have a dy. The y's of the section where the blue is the outer goes from 1 to 2. Our outer radius would be that length. It's a horizontal line connected to the y-axis, so that is just x. Well, for that outer radius, x is just equal to y. So we'll have pi times y squared minus pi times our inner radius squared, which is just 1, plus our second integral, the green section there, goes from 2 all the way up to 4. And all that's going to switch is our outer function, which is y equals 4x, but we need that with x by itself. So if you cross multiply, you get xy equals 4, so that'll be x equals 4 over y. So our outer will have pi times 4 over y squared minus pi times the inner, which is 1 squared, and dy. And again, the reason we need to do this separately is because the outer function switches. So we will have pi from 1 to 2, y squared minus 1, dy, plus integral from 2 to 4. Oops, I guess we should throw the pi out front. We're going to write this as 16y to the negative 2, because it's really 16 over y squared, minus 1 dy. We'll take our antiderivative. We'll have pi. We'll have 1/3 y to the third minus y, evaluated from 1 to 2, plus pi. Our exponent will go up 1, so we'll have y to the negative 1. Divide by that out front, so we'll have a negative 16. So negative 16y to the negative 1 minus y, evaluated from 2 to 4. So we'll now have pi. When we sub in 2, 2 cubed is 8 times a third, we'll get 8/3. Minus 2. Minus, we'll start a parenthesis, sub in 1, we'll get 1/3. Sub in 1 again, we'll get negative 1. Plus pi, sub in 4. 4 to the negative 1 really means 4 goes to the bottom. So negative 16 over 4 will give us negative 4. Sub in 4 for y, we'll get another negative 4. Minus and parentheses. Sub in 2. 2 to the negative 1 goes to the bottom. So that's really negative 16 over 2, which is negative 8. Sub in 2 for y, you'll get minus 2. And you can pull the pi all the way out to the front, type everything in, and you will end up getting 10 pi over 3. So that was doing it by washers. We'll now do it by shells. For shells, we will draw in our slices parallel to what we're rotating around. So they'll be parallel to the y-axis, so the thickness will now be in the x direction. So we will be doing dx. Our x's of our region go from 1 to 2. I'm going to throw the 2 pi out here times our radius for those slices. Well, maybe that's a slice. Its radius would just end up being x, because it's a horizontal line attached to the y-axis. And then we got to multiply by the height of each slice. Well, the height of each slice is this with that chopped off. So what it is it's our outer y, so I'm going to call it yo, minus our inner y, so I'm going to call it yi. Well, our outer y was our curved function, which was 4 over x, and we're doing it in terms of x, that's why we put it in there, and our inner y was x. So if we take our outer function and chop off the y equals x, that leaves us with the height of our slice. So we'll have 4 over x minus x. So that's 2 pi times our radius times our height. We'll distribute that x through, so we'll have 2 pi from 1 to 2. We'll end up with 4 minus x squared dx. We'll take our antiderivative, which would give us 4x minus 1/3 x to the third, evaluated from 1 to 2. That'll give us 2 pi. Sub in the 2, we get 8. Sub in the 2, we get negative 8/3, minus parenthesis. Sub in 1, we get 4. Sub in 1 again, we get negative 1/3. Type it all in, and we'll find we get 10 pi over 3 again. So this one, we were able to do it either way. Probably shells was a little bit quicker because you did not have to split it up like you did with washers. That's it for this video. We'll see you next class, period.